Hey kids! We are going to do another video for Module 1. This one is Lesson 9. And I kind of have, it's going to be so close to Lesson 10, but Lesson 10 is subtraction. So we'll come back to that on another video. For now, we are just adding. So the objective is to add decimals using place value strategies and relate those to a written method. All your parents are going to say, just line up the decimals and add. And they're absolutely correct, and that is how you do everything. So keep that in mind as we go through all this complicated strategy that our Common Core math is trying to teach us. Take a deep breath. First thing, really think about place value positions. Second thing, they're going to perhaps talk about place value discs. Now those are just dots or something to mark instead of a number. It's actually counting pieces. Also, they're going to talk about numbers in unit form, which is telling you the number plus the place value position. So for example, these are going to look like 2/10 plus 6/10 unit form. Here's how it is with the place value discs. 2 plus 6. So of course, it's 8, and here's 8, but in unit form it's 8/10. It gets a little bit more complicated looking when we have bigger numbers, but everything connects to place value. So kind of like on the mid-module test and the test prep, where they put things out of order, you may see things out of order, but now it's not going to confuse you because you know where the numbers belong and in which place value positions, and then you can line them up by just placing them where they go. So even if there are zeros, it's not going to fool you because you know where they go. So if I have 2 ones and 3 thousandths, you know that you will have zeros in the tenths and hundredths positions. Okay, so we're just kind of thinking about numbers and how to write them and how to read them and how to add them now, but using place value strategies. So here are a few more samples. 74 hundredths, here's the 7, here's the 4, putting it together with 59. This time I have regrouping. Every time you have a group of 10 place value discs, you regroup it, combine the 10, but because we have a base 10 number system, you have to take it out of this position and bump 1 into the higher place value position. This is all about like lesson 1, where a digit here has 10 times the value of the digit here. 10 times the value. So 10 of these make 1 of these. Same thing here. 10 of these make 1 of these. That's why I have them bundled and regrouped. If I rename it here, I don't count it anymore in this column. So when you combine in the standard algorithm, you see, well, 9 plus 4 is 13. So if I know I have 13 in my hundredths place here, I have the 3 that are left here after I've regrouped that 10 over to the next place value position. So that's what's happening here. We will go over this a lot more in class, but for those of you not in my class, that's what's happening. So you start in the positions to the right. If I have 4 here with nothing else, that's your answer, 4. 4 plus 0 is 4. But 7 plus 4 is 11. So you've got these 10 that you regroup into 1 in the higher position. This 1 stays behind. That's the 1 that is the answer. 7 and 4 is 11, plus that 1 makes 12. The 2 goes down, but regroup those 10 into the higher position so that you can combine that one with the numbers in, or the digits or the place value discs in the higher value column. So that's what that all is about. There's also a little bit of help with these notes. Unit form is going to be the number with the word of the place value position. So we'll start adding things that are like value, and then we'll start combining things that are not like value. And then it ends up kind of like this, but you'll get the hang of it. So not to fret. Let's jump into the book. Okay, lesson 9, problem set. So solve and then write the sum, that's the answer to an addition problem, in standard form. Just the answer. Now, the biggest caution here is watch out for all these equal signs, because we're going to be adding and then writing an answer and then add and then like rewriting it. So you have to kind of keep an eye on how we're going to be rewriting it. Like, how many times do I write the same thing? It really throws people off. So 1/10 plus 2/10. This is your problem here. And you say, easy, 3/10. Good. This is where the full unit form answer is, but this is where the standard form answer goes. So write your 3/10 in standard form here. 14/10 and 9/10. Again, we've got the like units. And so if you were using a place value chart, you would just add your 14 plus 9. You get 23/10. But watch for the equal sign, because now they're breaking it up into how many ones and how many tenths. Now, I don't like doing this step before I get a really good look at my standard form. They probably want you to think about it so you can write it correctly, but I want to write it correctly so I can break it apart. So if I have 23/10, remember that I would land here with my last digit. It would look like this, which means I have 2 ones and 3/10. Okay, so that's how that's going to look in unit form and standard form. Let's do another one. These are the same units. So 1/100th and 2/100ths makes 3/100ths. What does that look like? All we have to do is write it in standard form, 3 in the hundredths place. 27/100ths plus 5/100ths. So it's really 27 plus 5, all the same unit, makes 32. Watch for these little equal signs so you can answer correctly. If I have 32/100ths, notice that we have to take it apart here because we have these 2 digits. They want us to show that we can break it apart. But I want 32/100ths. I'm going to the hundredths place, and so I need 3/10 2/100ths. Another one, 1,000th plus 2,000ths is 3,000ths. Let's just put it in standard form, tenths, hundredths, thousandths. How about 35,000ths and 8,000ths? So that would be a total, watch for the equal signs, the answer, 43,000ths. Looks like this. Watch out. No tenths, okay? No tenths. This is all together, but 4 and 3. 400ths, 3,000ths. 400ths, 3,000ths. Then we have 6/10 plus 3,000ths. So watch out. So you can have each digit in the proper place. If I have 6 in the tenths place, do I have any hundredths? No, but I do have 3,000ths. So that's going to look like this. You can hold this spot with a 0. You can also think about it in terms of 3,000ths plus 6/10. And then in the standard algorithm, you'll be lining it up by place value position, which makes it fun and easy to add because the only things that have value are the 6 and the 3 in those positions. Bring down the decimal. Here's your standard form. And we have a total of 603,000ths. Okay? So lining things up is going to be very, very helpful, which is what we'll do when we get to the standard algorithm below. So for this one, I have 7 ones and 2/10. 7 ones, 2/10. So what does that look like? 7 in the ones place, 2 in the tenths place. You could also say 72/10. Plus 4/10. Put 4 in the tenths place. So how many total tenths do we have? 72/10 plus 4/10 makes 76/10 in unit form. And then that would actually look like this, because remember, this is the tenths place, and we need to have our standard form stop there in the tenths. Okay, for the last one, 2,000ths plus 9 ones, 5,000ths. So we're going to, if you use your standard algorithm, we'll be moving this over, or you can just add the 2 and the 5 and get 9,007 thousandths, which would look like it's got to end up, now watch out, tenths, hundredths, thousandths, but I have a 4-digit number. So we're going to use 9007, but don't forget 9.007. Okay? So I hope that's pretty clear. I know it can be confusing. You're like, I just want to add, Well, let's just add. So we're going to solve using the standard algorithm, but you must show your work here. So line everything up by where the decimal is. Anchor your problem with the decimal. Notice this has 2 digits, a 0 and a 3. This one has 3 digits, a 0 and an 8 and a 2. Line up the decimals. 0.82. Notice that there's nothing here. If you want to box it out, like I say, put everything into a box by putting zeros at the end, you can do that, or you can leave it blank. 2 plus 0 is 2, 8, 9, 10, 11, carry the 1, bring down your decimal. I like to sing it in Beethoven style, decimal down, and then bring down your 1, write your final answer on the line. But box it out, fill in with zeros if needed, and we just add in these columns. Noting that if you have to regroup, the extra 10 goes to the position to the left, because as you're regrouping, the greater value is to the left. 1.03, 0.08, add 8, 9, 10, 11, carry the 1 falls down, decimal down, and 1. Next one. These have the same number of digits, but caution, do they have the same location? Yes, they do. Ones and tenths. 8, 9, 10, 11. Decimal down, 7, 8, 9, 10. It's fun to just say that. Decimal down. And finally, 57 and 300ths plus 2.08. Watch out. 2.08. Lots of adding to 11. 8, 9, 10, 11. Regroup, carry that 1. It falls over. It goes up and over and falls down. Decimal down. 7 plus 2 is 9. And 5. 59 and 11 hundredths. Easy peasy. Okay, top of the next. Continue with the standard algorithm. These are bigger, so therefore possibly more complicated. Not for you, though, because you know what you're doing. 62 and 573 thousandths. Write neatly. I can't express that enough. Like, you need to be neat with your writing and line up these columns totally vertically. 4.328, 4.328. Be careful and be neat. 8, 9, 10, 11. Do you think they're trying to teach you what 8 plus 3 is? I think maybe. 7, 8, 9, 10. 5, 8, 9. Decimal down. 4 and 2 is 6, and there's a 6. 0.901. And finally, 85 and 703 thousandths. And 12 and 197 thousandths. Adding and line up those decimals to add. 7 plus 3 is 10. The 0 goes down, the 1 goes up. 9 plus 1 is 10. The 0 goes down, the 1 goes up. 7, 8, 9. 9 and decimal down. Don't forget your decimal. It will completely change your answer and make it wrong if you forget it. 5 plus 2 is 7. No regrouping necessary. 8 plus 1 is 9. Write your final answer up here. Make that decimal nice and clear. Okay, word problems. Let's take our skills and apply them. Van Cortlandt Park's walking trail is 1 200 kilometers longer than Marine Park's. Central Park's walking trail is 242 thousandths kilometers longer than Van Cortlandt's. So fill in the missing information in the chart below. So I do have Marine Park's distance right here in kilometers. And we're comparing with Van Cortlandt here at the beginning. And they're saying Van Cortlandt is this much longer than Marine Park. So I'm going to take Marine Park, 1.28. okay, kilometers. And I'm going to add on the extra distance so I can find the total of Van Cortlandt. So 1.02 kilometers. Notice it's the same unit, so we're okay to combine these without converting anything. 8 plus 2 is 10, 2 plus 1 is 3, decimal down, don't forget, and there's your 2. So how far around, what's the walking trail around Van Cortlandt? 2 and 30 hundredths. You could also put 2.3, and that is equivalent, and you would be okay. Next part, Central Park's walking trail is 242 thousandths kilometer longer than Van Cortlandt. Now that I know Van Cortlandt, I can take that and I can add 242 thousandths to that distance. And you could put a 0 here if you wish to square that set. Sounds like we're doing a country dance. Square your set. Okay. And then add those distances to find the total distance around Central Park. So 2 plus 0, 4 plus 0, 3 and 2 is 5, decimal down, and there's your 2. Distance around Central Park, 2.542 kilometers. So that's A. Hooray, done with that. Now, if a tourist, I hope that's me, walked all 3 trails in a day, how many kilometers would he or she have walked? So all 3 trails, that's pretty easy. We're going to put them together. 5, 4, 2. Biggest mistake kids make here is to copy wrong. Do whatever it takes to copy right. 2.542, 1.28, 1.28. Say them, write them, check them, fill in. 2.30, 2.30. Notice that I do repeat that a lot. I will say the number, and then I will write it, and then I will check it. And even I make mistakes, so everybody makes mistakes. Let's add these. 2 comes down. 8 and 4 is 12. Carry the 1. 5, 8, 9, 10. I'm always trying to make a 10. And then plus 1 is 11. 4, 5, 6. And you should end up with 6 and 122 thousandths kilometers. That's a real nice walk there that someone would have walked. He or she, or you can put the tourist, would walk 6 and 122 thousandths kilometers. There you go. Oh, there go the lights. But look, I have a little light on in my room. Ha-ha! I am beating the motion sensor. Okay, sorry. Here we go on the last one. Meyer has, oh, this is such a great problem. Very realistic. Meyer has 6,400 gigabyte of space remaining on his iPod. If you think about your iPod and you have storage space, so it's like this is all taken up with your apps, okay? But he has, or she, has this much left, 6,400 gigabyte remaining. Okay, so this is available for new apps, new games, things you want to play. But he wants to download, he wants to download a pedometer app, which is 2,400 gigabytes, a photo app, 403,000 gigabyte, and a math app, 0.3 gigabyte. Which combination of apps can he download? And explain your thinking. So if he's got the 64 hundredths of space, looking at this one and seeing that I have 4 in the tenths and 3 in the tenths for the map app, that right there is 7 tenths. If 6 is the only thing, so like I'm comparing in my head, I haven't even shown any work yet. If 6,400 gigabytes is all he has left, I can't use all the apps together. So I have to look for certain combinations. Let me show you what I'm thinking of right here. So if I combine the photo and the math, then I end up with too much. This is too big because I only have, essentially, you can put the 0 there, 640 thousandths max, okay? So that's how much room I have. 703 is too big. Okay, so we're looking for the Goldilocks amount. What is just right? Okay, how about the pedometer app and the photo app? So what if I have 24 hundredths here, and then I have 403 here? Fill in with the 0. Let's add it up and see what we get. 643. And what is the max? 640. So what you're doing is you're comparing 640 to 643. If this is too big and I need this one, then that won't work either. And so the 240 was the PED, and we're labeling it so we can be clear, photo, about what does and doesn't work. So we did the photo and the math, and the photo and the PED. So let's try a different combo. Let's do the pedometer and the math. And we can box that out and add up. And what do we get? Decimal down. And we get 54 hundredths. So if the PED app and the math app have enough gigabytes combined to allow us to have a number that is, when compared, less than the 6400th, this combination would work. Okay, so the pedometer and the math app are going to be the combination that work. So we must find a sum less than 640 thousandths. Okay, and we found one, and it's the pedometer and math. So yay, hope this video has been helpful. Come back, click subscribe, come back again, and I will try to help you on some more videos. We'll see you on the next one. Bye.